Can a supercomputer figure out the formula for chocolate ice cream? Hit the start button. Write in chocolate ice cream. The computer can't tell you how to make chocolate ice cream unless you explain to the computer in significant detail. Then the computer could analyze a dessert and say, just like that, that's chocolate ice cream. But it's got to be programmed first. And the programmer has to understand the formula for chocolate ice cream. I suppose somebody who made chocolate ice cream for a living would pretty much understand chocolate ice cream. But the climate is far more complicated than the formula for chocolate ice cream. And before a computer can do you any good, you've got to give it the information it needs before it can calculate a useful conclusion. A supercomputer cannot predict the climate 100 years from now without the necessary information programmed in. I don't believe these guys use a supercomputer. I believe these guys, the Hadley Centre in England, that puts out this chart called HAD-CRUT. HAD-CRUT. I don't know what that stands for. I hope I never find out. It shows, oh my God, 1 degree temperature rise per century. That's just extreme. 1 degree in a century. That's never happened before. They knew it had happened before. They knew that that is routine because they had Al Gore's Vostok data points from day one. They had the original data points. I'm going to show you those data points. And I'm going to prove to you that a 1 degree rise in temperature, or in this case, I'm going to show you it's a 3 degree drop in a century. In 100 years, the temperature moved by 3 degrees, and they are screaming that the sky is falling because our temperature in the past 100 years has increased 1 degree. This is incredibly simple. You have essentially 3 data columns. The first one is the depth taken in meters. Here are the first 10 samples that they took from the ice. The second column is the age of the ice. They had some way of determining the age of the ice. And the third column is the temperature column based on the deuterium content. They extrapolated this to get a temperature reading. However, the first 7 samples yielded no temperature information. So the Vostok ice core chart actually begins with sample number 8, which is at 149 years ago, where the temperature was 0.81 degrees below today's temperature. This is where we start. What we would do now at this point is to take these data points and plot them on a chart, just like putting little dots on graph paper. So I began to plot my dots on my graph paper, and I was studying carefully to put the first one at 149 years and 0.81 below 0, which is today's temperature. And my mind began to wander, and I noticed that this is not very much time. The difference between 149 years and 190 years is just 41 years, and the temperature has moved more than 1 degree in a short space of 41 years. So if you get out your calculator and divide 1.17 by 41, you'll get the rate of change per year. Multiply that times 100 to get the rate of change per century. So if you glance at a chart of this data, you can see that this rate of change is typical. This rate of change is all over the place. But what about CO2? What is CO2 doing while the temperature is all over the place? Well, it's just slowly creeping up. And the ice core's record of CO2 begins 2,500 years in the past. They don't have any record of the most recent 2,500 years. But you can see it is already going up slowly.